what is the advantages of using what we call the isothermal? So isothermal means the temperature is we could like to say revisit isothermal process. We are interested on isothermal process, how it doing the work. Okay, so this is a P diagram and PV diagram. So we go in like this fashion. And T is constant. T is equal to constant. So isothermal process, T equal to constant. But we are dealing with ideal gas. So picture this. This is a piston, go up and down. And here is a volume, V, maybe V sub I. And when you move up in here, become the V sub F. Okay, so here you go, but P is not constant, T is constant. So what, how we going to do it is W is equal to minus P dV. Okay, that's the reason why you need the information on the chapter 16. According to ideal gas law, according to ideal gas law, according to ideal gas law, then PV is equal to nRT. So then P is equal to nRT divided by V. So this is equation number 1, equation number 2, equation number 3. Due to the fact T is constant, we can substitute the value of P into equation number 1. So the W will give us this. W is equal to minus integration of nRT divided by V dV. Okay. So after we doing this, then we integrate because T is constant, so V sub I to V sub N. So in that cases, you have minus nRT is constant. And then you integration of V sub I, V sub F, dV divided by the V. So ladies and gentlemen, dV divided by V integration equal to what? Log? Ln. Yeah. Chris, you're doing okay. As an art major, you're doing perfect. Oh, you did. So your school, the requirement is unusual for art major, right? So V sub I, V sub F, that equal to minus nRT log V sub F divided by V sub I. So the work in thermal process, in isothermal process, is equal to minus nRT times log V sub F divided by V sub I. See how nice? This is isothermal process. So this is the work done. This is the work done on gas. So what is work by the gas? What's the difference? The sign. Plus is work done by gas. So make sure distinguish this difference, especially on the test, adiabatic process. So the adiabatic process, the whole section of it is on two sections. So we will leave up to the student to study, because that is maybe is related with the final test problem. In which case, the section 17.7 section with what we call adiabatic processing. This one is called adiabatic processing. The process. During the adiabatic process, because there's a no heat loss condition, during this way, the pressure on the boiler, the product of this, product of a PV to V to the gamma. In that case, that is equal constant. This is the adiabatic condition. PV gamma. So then what is gamma then? Gamma is a constant, of course. Is a ratio. So gamma is equal to the ratio between the specific heat under constant pressure P boiler. So that is gamma. So this is called derivation. So PV gamma is how you derive it. Derivation. So we need you to take a look at it, and I might give that on the test problem. Okay, so then the last important section on chapter 17 is 17.10. This one, for your final, even though it covers only one section, but we need the test on this, okay? So in this case is 17.10 heat transfer. This is a heat transfer. How you're going to move the heat? That's the key. Okay. So then the first one, number one item, we call heat convection. A lot of this idea is very important in construction. Especially civil engineer, mechanical engineer, a lot of time you have to deal with this as a real issue. The first of all, for heat convection is the molecular movement depends upon temperature. So if an air molecule, if the temperature is high, then what is is the air density is low. If the air density is low, then hot air move up. So this is the condition. That means when you're heating air is become hot, then it move up. This is the mass movement. So now the next thing is when the temperature is low, then air density is high. So what it does, cold air move down. So move down. So this is the situation. So if you want to transfer the heat by nature, you have to obey this rule. Obey this rule. So when you're building a house, you like to build it properly. So here is my suggestion. So here is air. Here is house. So what is the best way to accommodate this? You put what we call the heater in here. So heater is here. So near the floor or prevent the safety. So for safety. So when the air particle move up and when it cool down, it cool down. So if you want to getting better, then you put two air heater underneath, okay, and then near the ground. And then the next thing is on the top, you like to put air conditioner. So when you have air conditioner on the top, so what happens? The cold air is going down naturally. Cold air. I bought a house, in which case it's bad news. But the designer of our house, stupid architect. What they did is put a heater on the top. So what happened? So when the cold weather will come, all the hot air is on the second floor. The cold air is still down below. Sad, right? When the cold weather comes, I say, stupid designer, stupid architect, you know. And I don't want to spend money to what they call to remodel. Too much money for remodel. I just need it. So